Alright, welcome wonderful people. This is Mr. Ndabezita once again, and this time we will try and look at physics grade 12, and we are in module 1 where we will be dealing with mechanics. So mechanics is the study of the effects of forces that act on matter. So matter being anything that occupies space and display the properties of mass and inertia. This is very true. And they say in grade 10 and grade 11 you were introduced to the equations of horizontal motion, which we will look at. And then they say in this module we introduce the concept of momentum and impulse. And they say momentum measures the effect of mass and velocity of an object on its motion. So this is the definition of what momentum is. So in momentum, we look at the effect of mass and velocity that is acting upon an object. Somebody might say that momentum is the product of mass multiplied by the velocity, or somebody might say that momentum is an indication of how difficult it is to stop a moving object that is a certain amount of mass and moving with a certain amount of speed. So right, when objects collide, we use this concept to explain what happens to each object after the collision. So when two objects collide, we would want to know the momentum that an object has and the impact therefore it will have on the other object, because we are speaking in terms of collision here. We will use our knowledge of momentum to derive the concept of impulse. Okay, that is fine. The effect of a net force is determined by the amount of time that it is applied. Many of the things that are said in here, I think we will look at them as time goes on. Right, we have a physical constant used in these units, and the gravitational acceleration that will be a constant which we use will be 9.8 meters per second squared. Okay, that is fine. Let us look at momentum and impulse. And then what is it that we want to say here? We are familiar with many of the quantities that we encounter in physics. Often we have a sense of what they mean, and then they give so many examples. And then if we continue, they say, consider two balls rolling on a smooth horizontal surface at the same constant velocity. One ball has a large mass and the other has a small mass. Which ball is easier to stop? Obviously the one with a lesser mass. Right, and then they say this combination of mass and velocity determines the quantity of motion of an object. We can increase the quantity of motion by increasing the mass of the object or the velocity of the object, or both the mass and velocity, because we said that momentum is the product of mass and velocity. So in order to increase the momentum of an object, you can increase mass or velocity, or you can increase both. Right, this quantity of motion is called momentum. Which quantity now? The quantity of this product, mass multiplied by velocity, we call that quantity momentum. Now the momentum of an object is the product of the mass of the object and its velocity, and it's a vector quantity, something worthy of noting. So momentum is the product of mass and velocity, and remember that momentum, it's a vector quantity because velocity is a vector quantity. So obviously momentum will be in the direction through which an object is moving, because an object that has a velocity has to be moving in a certain direction. So as a consequence of this, momentum itself is a vector quantity. You have to specify the direction through which this momentum has been calculated, because it is a product of mass and velocity. where P is the momentum, and this is measured in kilogram meter per second. Why? Because mass is in kilograms and velocity is in meters per second. Therefore, the SI unit of momentum is kilogram meter per second. This is something worthy of noting. So if I say per there, I can use a positive 1 there because I have a per. Or somebody might just say kilogram meter per second. If you use multiplication here, you will say minus 1. If you use the division there, let me just do this. If we say kilogram meter per second, if I use it like this, you have per second, this would be positive, but we can just go for this one, kilogram meter per second, because I did not include the division line there. Okay, that is fine. And then we know that mass is a scalar quantity, velocity is a vector, so therefore momentum will also be a vector quantity. Right, let us try to look at some of the examples that might give us an insight view as to how this momentum actually works. They say a 5 kilogram block is moving in a straight line at 2 meters per second towards the left. Determine the momentum of the box. So everything that occupies space and has a velocity, we can calculate the momentum of that object. So let us try to draw the situation. So we have a box of 5 kilogram. It is moving in the left. It is heading to the left. Therefore, this would be a vector quantity because direction is provided. So the velocity is 2 meters per second and the mass is 5 kilogram. And we can calculate the momentum as a product of mass multiplied by the velocity. Mass is 5, velocity is 2 meters per second. 2 times 5 is 10 kilogram meter per second. And remember, because momentum is a vector quantity, you need to specify the direction. So this is to the left. So momentum, it's in the left direction with a magnitude or a size of 10 kilogram meter per second. So this would be your momentum. So this object has this momentum, which is the product of mass and velocity. So, and it is directly proportional to mass and velocity. The momentum is directly proportional to those two. So this would be the momentum of this object. So what is important is to note the direction. Always and always, momentum is in the direction of velocity. Something worthy of noting. Now let us look at the second problem. They say an athlete has a mass of 60 kilograms. So this athlete has a mass of 60 kilograms and a constant momentum, and the momentum is given as 96 kilogram meter per second in an easterly direction. So this is east because remember it's a vector quantity, and what makes this a vector is because velocity is a vector. Right, determine the velocity of the athlete. So we are looking for velocity. Momentum is the product of mass and velocity. Right, so we have momentum, which is 96 kilogram meter per second, is equals to 60 kilograms multiplied by velocity. And we know that momentum is in the same direction as velocity, and velocity is in the direction of the momentum. So if I'm looking for V, I can divide both sides by 60 kilograms. 60 kilograms. Please be very careful there. You don't just divide by 60, you're dividing by 60 kilograms. So this into this will go once. Velocity as a vector, kilogram will cancel with a kilogram. You will be left with 96 meter per second divided by 60. And then from there we can find what the value would be. So I can try and use long division in here. I can try and use long division, but it is not necessary to do that. Let me just go to the calculator and find out what the velocity would be. So we get a value of 1.6. Remember, this is velocity. That would be meters per second east. Why east? It's simply because the momentum, it's in the easterly direction, therefore velocity would also be in the easterly direction. Remember, they are both vectors. So this is what you can get there. So this would be the velocity, and it will be positive if we consider movement to the east as being positive. So in physics, it is very important that we choose the direction to say that let east direction be positive. So this is positive because we have allowed the easterly direction to be positive. Okay, that is fine, there is no problem. Now let us try to change some gears. So this is just the basic of understanding momentum. Momentum is the product of mass and velocity, and momentum, it's in the direction of velocity. Velocity, it's in the direction of momentum, and the SI unit of momentum is kilogram meter per second, and momentum is directly proportional to mass and velocity. And if you want to increase the momentum of the object, you can either increase the mass or you can increase the velocity, or the combination of those two. Now let us try to look at the change in momentum now. They say the vector nature of velocity determines the vector nature of momentum. This is very true. So vector nature referring to the direction through which the velocity is moving. So the direction of velocity gives the nature direction of momentum. So we are therefore saying momentum and the velocity are always in the same direction, as we have saw that just in this previous problem. Velocity and momentum are always in the same direction. Hence we said in here, because momentum was in the easterly direction, therefore velocity will also be in the easterly direction. This is to say momentum and velocity always head towards the same direction when the mass and the velocity of an object remain constant. So if mass and velocity remains constant, the momentum of the object also remain constant. Why? Because there's a direct proportional relationship between those three. The mass of most objects remain constant during their motion. When the velocity of an object changes, the momentum also changes because they are in the same direction. The change in momentum is the difference between the initial momentum and the final momentum. So an object can move with an initial momentum heading for a final momentum. So we indicate this change as follows. We use the delta sign. So this is what we call the delta sign, and the change in momentum is the final momentum minus the initial momentum. So an object can have initial momentum having initial velocity, and it can have a final momentum having the final velocity. And as we continue in this is going to become very, very clear. So we can say that the change in momentum equals final momentum minus initial momentum. This is very, very important, and these are equal. This is highly and highly important. So change in momentum is a final momentum minus initial momentum. Something worthy of noting. Very much worthy of noting. Right. Without looking at so much theory, let's try to apply this on a practical level. So we have the following information. They say to us, let me just try to zoom in very good. They say a car with a mass of 600 kilograms travels in an easterly direction along a straight horizontal road at a constant velocity of 20 meters per second. Full stop. The driver suddenly increases his velocity to a constant velocity of 24 meters per second and continues driving in the original direction. The first question says determine the change in momentum of the car. Right, let's just try to stop there. Let me draw up a line, and I'm going to write down data as slowly as we can. So a car with a mass of 600 kilogram travels in an easterly direction along a straight horizontal road at a constant velocity of 20 meters per second. So the initial velocity is 20 meters per second. Right, let me just write it in this way. Let me say vi equals 20 meters per second. Very good. So this is the first information that we have. So this would depict initial momentum because we have initial velocity. Secondly, it says the driver suddenly increases his velocity to a constant velocity of 24. So V final is 24 meters per second and continues to drive in the original direction. Now remember where they are heading. Remember that the car is heading, or it is moving on a straight horizontal road. Right, so let's say the car is heading in this direction, in the easterly direction. Right, now the first question, they say determine the change in momentum of the car. A change in momentum is final momentum minus initial momentum, right, which is equals to mvf minus mvi. This would be the final momentum minus initial momentum, and there's something common on both, which is mass, and I will be left with vf minus vi. Very good. So what is the mass? This is the same car, just that the car has increased or decreased its velocity. So the car is the same. It's a car of 600 kilograms. What was the final velocity? 24. Remember, the velocity was just increased. There was no change in direction. You were moving with a velocity of 20. You apply the accelerator. The car now moves at 24. So this would be 24 meters per second minus 20 meters per second. And if we insert this on a calculator, 600 kilogram, 24 minus 20, that will give you 4 meters per second. Right, and then we can just say 6 times 4, 12 plus 12, it's 24. So we can just say 24 00 kilogram meter per second. So in which direction? In the easterly direction, or you can just say east. So the momentum would be 2400 kilogram meters per second east. That would be the change in momentum. Very, very important, change in momentum. And as you can see that the answer here is positive, meaning the final momentum is bigger than the initial momentum. This is very, very important that we see that. So meaning if the velocity increases, that will imply an increase in momentum. So because the velocity was increased, obviously the momentum would also increase. So vf minus vi will provide us with the answer that we have there. So this is the change in momentum. That was the first problem, A. But we still have a B to deal with. And B says draw a vector diagram to illustrate the relationship between the initial momentum, the final momentum, and the change in momentum of the car. And this is exactly what we are going to do. Now, let us look at this. We said now the change in momentum equals final momentum minus initial momentum, which is mvf minus mvr. Now, let's look into this. Let's just calculate the final momentum, which is mvf. 600 kilogram multiplied by 24 meters per second. And this would give us a value of let's just look into this. I'm going to apply long multiplication here. 600 multiplied by 24. So I'm going to say 4 times 0, 4 times 0, and 4 times 600. And this would give me 2400. Right, that is fine. That is 2400. All right, this is fine. And I'm going to say, okay, that was 4 multiplying this. Now I'm going to say 20. Oh, okay, sorry, let me not do it in this way. I'm sorry, let me not even go there. Let me just go straight into a calculator so that we don't consume a lot of time. Let's just say 600 multiplied by 24, and that would give us 14,400. So we get 14,400 kilogram meter per second east. This is the final momentum. Let's find the initial momentum. Now the initial momentum will be the same mass of 6 kilogram. Remember, we are speaking of the same car that just changes the velocity. What was the initial velocity? It was 20 meters per second. Right, and then I would say 6 times 2, it's 12. Write down your 3 zeros. Kilogram meter per second east. So obviously, let me just try to do the following. Obviously this is bigger than that. So if I have to show this, please be very careful. If I have to show this, so how will I do that? So I will have my let me just follow the logic of the question. It said draw a vector diagram to illustrate the relationship between the initial momentum, the final, and the change. So I would obviously have the final, because the number it's very bigger, it's 14,400. so this will be the final momentum. The initial one, it's 12,000. This would be the initial one. So let's just say this would be P initial with a value of 12. And then let's now find the change. And the change, it's 24. Sorry, the change is 2,400. So if the change is 2,400, obviously it is a smaller. So this would be the change. Do you see that? So this is 2,400, this is 12,000, and this is 14,400. So this is how I would illustrate this. But there's a second way in which we can do this, and I want you to be very careful of this. I can have my final momentum, very, very important, moving in that direction. And then secondly, what I can have my initial. This would be the initial momentum, and this would be the final the change. This would be the change in momentum. So this is the final momentum, this is the initial, and this is the change. And the sum, I want you to be very careful here. The sum of initial and change must give you the final. How do I know this? Let's check. Change in momentum equals final momentum minus initial momentum. And look what is happening. Take this to the other side. Change in momentum plus initial momentum equals final momentum. Do you see where I get that? So final must be equals to the sum of the change and the initial. Hence I drew this. The sum of initial and the change must give you the final. Do you see this? So never and ever draw that. The mathematical law, which is this, shows us that the change plus the initial has to give you the final. So this is the final. The length of the vector is the magnitude and the arrowhead points in the direction. So the length of these two vectors must give you the sum of the final. Something worthy of noting. Highly worthy of noting. Right, okay, that is fine. Let us try to check something else. Let's just try to go to example 4. They say a 3 kilogram block slides along a horizontal frictionless path, which is AB, as shown in the diagram, at a velocity of 1.5 meters per second in a straight line. It passes over a small rough patch, which is BC. Okay, that is fine. The box then continues in its original direction along the frictionless path CD at a constant velocity of 1 meter per second. Now let me just draw this for you. So suppose we have a horizontal table and so on. So we have a box of 3 kilogram which slides along a horizontal frictionless path AB. So let's allow this to be A and B there. Okay, that is fine. And it is moving at a constant velocity of 1.5 meters per second. So this would be the velocity of this block. That is fine. In a straight line, that is fine. It passes over a small rough patch BC. So let's say this is BC and this is a rough patch. Okay, the box then continues in its original direction along the frictionless path CD. So this one is a frictionless CD, and it is now moving from C to D at a velocity of 1 meter per second. Right, that is fine. Now what is the question? It says in number A, determine the change in momentum of the box. Okay, one thing that we know is that the change in momentum is final momentum minus initial momentum. Okay, and I know this is mvf minus mvi, and I know the mass is 3 kilogram. I have already factored mass, and the final velocity, that would obviously give me a value of 1 meter per second. That would minus 1.5 meter per second, and this would give me 3 kilogram. 1 minus 1.5 is minus 0.5 meter per second, and that should give us a negative value, and the negative value would be negative 1.5 kilogram meters per second. In which direction? Now we find a value that is negative. so meaning in the opposite direction. If the box was heading east, therefore we would say northeast, southwest. So we can say west, or we can say in the opposite direction of motion. So this would be the change in momentum. This is worthy of noting. And why is it negative? That is because the initial momentum is bigger than the final momentum, and as a result of that, the initial momentum is negative. So therefore the object is no longer going east, it is now moving in the opposite direction. So the object was heading in this direction from A to B. It came across a rough patch BC. Obviously the velocity was decreased from 1.5 to 1 when it reaches C going to D, and as a result of that there was a change in velocity. The final velocity is now 1, the initial is now 1.5. So final, which is 1 minus 1.5, obviously it will give you a negative value. So meaning the object momentum is no longer heading that direction, it is moving in the opposite direction. Very important. B. Use a vector diagram to illustrate the relationship between initial, final, and change in momentum. They are asking for exactly what we did in the previous. So this is what I'm going to do. Something worthy of noting. Now let us look at the following. Let us look at the final momentum, which is mvf, which is 3 kilogram multiplied by 1 meter per second, which is 3 kilogram meter per second. And where is the direction here? Please let us be very careful here. In which direction are we heading here? This is positive. Are we fine? Are we fine that this is positive? Yes. So let's just continue to go east. Now let us look at the initial momentum, which is mass multiplied by the initial velocity. 3 kilogram. What is the initial velocity? 1.5 meters per second. And what is the 3 multiplied by 1.5? That should give us 4.5 kilogram meters per second, and this is also going into the easterly direction. We are fine with this. Now if we are fine with that, let me just come here just to complete this. Now we want to find the change, and we know that PF, final momentum, is equals to the change in momentum plus the initial momentum. This is something that we know. Right, let us look at our final. Our final is a 3. This is our final, is a 3, and it is positive. Now let us look at which one is bigger in this case. Now the initial is bigger, and if we look here, I want to draw your attention here. In fact, let me do the following. I don't want to confuse you. Remember what we said. Let me do the following. We said the change in momentum equals final momentum minus initial momentum. And look what is happening. If I take this one, let's check something here. Remember the values that we found. We found that final momentum is equals to 3 kilogram meters per second, and the initial momentum was found to be 4.5 kilogram meters per second, and the change in momentum was found to be negative 1.5 kilogram meters per second west. These are the values that we found. Now let's check something. Because the bigger one is the initial momentum with a value of 4.5. Now what are we going to do now? We're going to take this one to the other side. Let me show you this. When I take this to the other side, we will have change in momentum plus initial momentum equals final momentum. Now take this one to the other side. Initial momentum equals final momentum minus change in momentum. Now this is exactly what we are going to draw. So meaning the sum of final, the difference of final and initial must give us, the difference of final momentum minus change must give us the initial. So I'm going to do this. And I'm going to say this is the initial momentum. What is the final momentum? Please be very careful. The value there is 4.5. Please be very, very careful there. So the value of the initial, it's 4.5. There it is. And what is the value of the final? This is a 3. Right, and it is moving in that easterly direction, so it is in the same direction as the initial momentum. So let's look at the final. The final should be 3, so this would be the value of the final. So this is the final momentum, and they are in the same direction as the initial, but remember the change is negative and it is heading in the opposite direction. So what will this be? This would be the change in momentum. So can you see this? This is something worthy of noting. In fact, let the arrow still point in this direction, because the negative only tells you that it is heading in the opposite direction. So this is something worthy of noting. Final momentum is in the same direction as the initial momentum. The change in momentum, it's also heading in that direction, but we know that it has a negative value showing that it is moving in the opposite direction. So you don't have to take an arrow and point it in that direction. No, let the arrow point in the very same direction, which is the east, but when you draw your magnitude with an arrowhead, it has to point in the opposite direction. So meaning the difference in this must give you the initial momentum. So final momentum minus change in momentum equals initial momentum. Something worthy of noting. Right, let us continue and look at example 5. They say a 100-gram tennis ball strikes a wall at 10 meters per second. So we have the mass, which is 100 gram. We have the initial velocity of 10 meters per second and bounces back in the opposite direction at 8 meters per second. So suppose this is a wall and this is the tennis ball. It is moving with this velocity of 10 meters per second, and then it bounces off and moves in the opposite direction, and the velocity is now 8 meters per second. So this would be the final and this would be the initial. Right, from there, what is it that they want? They say calculate the change in momentum of the ball. The change in momentum is final momentum minus initial momentum, which is mvf minus mvi. Taking m as a common factor, this is what we have. But whenever we are dealing with mass, mass has to always be in kilograms. So how do I convert from gram to kilogram? You divide by 1,000, which will be 100 divided by 1,000, which is 0.1. So this is 0.1 kilograms. What is the final velocity? So let motion to the east be positive. So if this is positive, obviously that would be negative. Something that is worthy of noting. So I will have negative 8 meters per second minus 10 meters per second. This is very, very important for you to see. Something worthy of noting. Something worthy of noting. So from there, what is it that we do? Now let us try to check what is happening here. So you have a final velocity, which is this, minus initial velocity, which is that, because we said, remember, we said let motion to the east be positive, therefore west will be negative. So this is negative and this is positive. So I will have 0,1 kilograms minus 8 minus 10 is minus 18 meters per second. So let us try to multiply the 0.1 times negative 18. So let me just check this very quickly for you. 0.1, and we multiply that by negative 18, and that would give us a value of negative 1.8. So the value is negative 1.8. Negative 1.8 kilogram meters per second. In which direction? Therefore, this would show us the magnitude. Remember, that would show us only the magnitude. So this is the change in momentum. But we know that the negative points in the opposite direction. So your momentum is negative 1.8 kilogram meters per second. But I did not show the direction here. So this would just to say 1.8 kilogram meters per second west. Negative only points in the direction. It has nothing to do with magnitude. Right, and then from there, what is it that we want to do? Number B, they say use a vector diagram to illustrate the relationship between initial, final, and change. So that is fine. We know that we can calculate the final momentum as mvf, which is 0.1 kilogram. We can multiply this by the velocity of the final, which is 8 meters per second, and that should give us a value of okay, let me just include that negative so that we can get negative 0.8 kilogram meters per second. So this negative is the direction of your velocity there. So velocity is moving in the opposite direction. So we will get negative 0.8 kilogram meters per second. We can also find the initial momentum, which is mvi, which is 0.1 kilogram. That is to be multiplied by 10 meters per second, because we said to take east as positive, and this would give you 1 kilogram meters per second east. So that would be the direction. So let us try to continue in this and check. We have final momentum, which is negative 0.8, and the initial is 1, and the change, it's negative 1.8. So which one is bigger? Initial momentum. So how are we going to draw these vectors that they are looking for? Because they say in number B, use the vector diagram to illustrate this change, and we have already dealt with this. Now let us check this. We know that the change in momentum is equals to final momentum minus initial momentum, and because the initial momentum is the positive one, we're going to take this one to the other side. So meaning if we take this to the other side, that would be the initial momentum is equals to final momentum minus the change in momentum. So the difference of those two should give you the initial. So let's try to do that. So we have the initial momentum, there it is, and then we have the final. So the final, it's negative 0.8, and the change, it's negative 1.8. So obviously negative 0.8 is bigger than negative 1.8, so that one would be bigger, which is the final. So this would be final momentum. And then remember, it is negative. I am sorry for that. It is negative, therefore I'm sorry, the arrowhead has to be in this direction. I'm very sorry. And then we have the change. The change is also negative. It will also point in that direction, which would be the change. So initial momentum would be equals to the difference in final momentum and change in momentum. And because both are heading in the opposite direction, therefore the arrowhead should point in that direction. Something that is very important, something that is worthy of noting. So remember, we said we found initial momentum as a positive, meaning it is heading towards the easterly direction. So these ones will go to the west. And let's look at something here. Change in momentum, it's negative. It's negative going in that direction. And final momentum is also negative going in that direction. But in here, this has to be positive and that has to be negative. In here, the initial momentum, final momentum is positive and the change is negative. Can you see that? I want you to see this. So this diagram does not illustrate that. The diagram illustrates the initial momentum as positive, but the final and the initial are both negative in the sense that they are heading west, and it violates this. So this diagram is wrong. We need to modify our diagram. So the only thing that is going to help us here, let us look. Do we have the final momentum? Yes, which is negative. Do we have the change? Yes, which is also negative. So the change is negative, and also the final, it is negative. Only the initial is positive. Now look into this. The change in momentum equals final momentum minus initial momentum. So take this to the other side. Change in momentum minus final momentum, this would be equals to minus initial momentum. And then we can divide everything by -1, so that we can have negative change in momentum plus final momentum, which is equals to the change in momentum. Can you see this? So we are saying in here, the initial momentum should be equals to minus change in momentum plus final momentum. I don't know if this is making sense, because why are we saying this? Final momentum is negative and the initial momentum is positive. I want you to see that. So if the change in momentum is negative and final momentum is negative but the initial momentum is positive, so meaning this is what we can do. We know that the change in momentum is negative, so let's do this. Let's try and do this. So this would be the change in momentum. something worthy of noting. And where is it heading? West. It is heading west because it is negative. Change in momentum is negative. If you look in here, it is heading west. Right, that is fine. Now let us try and look at initial momentum. It is positive, meaning it is heading east, and that value is bigger. And what is that value? That is 1, and it is the bigger value. So I'm going to do this. What is this? This is the initial momentum. And now look at the final momentum. It is negative. Therefore, we're going in that direction. And this would be the final momentum. Very good. So this is positive. This is negative. And what is this? This is also negative. So this is a better representation in terms of showing the vector diagram to illustrate the relationship between initial, final, and the change. So it is making sense in this way. It is making a lot of sense. So you have your change in momentum. Let's check if this is true. Minus change in momentum, that's exactly what we did. Minus change in momentum plus final velocity should give you the change, should give you the initial momentum. So if initial momentum is final, is positive, if this comes to that side, it becomes negative, and you are left with this. So this represents this. Please try to see that. Final momentum is positive, therefore there it is bigger because its value is bigger. It's 1. If you take this to the other side, the final momentum would be negative, there it is. And if you took this to this side, you are left with a negative momentum, and there it is. So minus momentum is equals to initial momentum minus final momentum. And this is exactly the illustration that we have. I know this might be a little bit confusing to some of you. Please sit down, try to look at this very thoroughly, and you will understand at the end of the day. So I'm going to leave you here. In the second tutorial, we're going to look at test problems, and then we will continue.